All right, moving right along, we are covering 8.3 in this video. So take notes. 8.3, the discriminant and quadratic in form. So 8.3, the discriminants and quadratic in form. So quadratic in form, those are equations that are quadratic in its structure. Okay, so let's start off with what the discriminant is. In the last section, we covered the quadratic formula. So the discriminant is the part of the quadratic formula that's under the square root. Okay, so the part of quadratic formula under square root. Okay, so let's go ahead and write down the quadratic formula. So it's x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. Okay, so the discriminant is the part that's underneath the square root. So it's this b squared minus 4ac part. Okay, so the discriminant is the b squared minus 4ac. Okay, and we use the discriminant to determine how many solutions our quadratic will have and the type. Okay, so like, is it going to be a real solution? Is it going to be a complex solution? So let's have a look here. So we use it to determine the number and type of solutions to the quadratic. Okay. Okay, before I give you what the rules are, let's just inspect the quadratic formula for a second. Let's suppose that we end up with this. Okay, so let's consider this. Suppose that we do our quadratic formula and we're getting x equals to 3 plus or minus the square root of 4. And then we do the quadratic formula and we get 3 plus or minus the square root of negative 4. Okay. And then we do the quadratic formula again and we get 3 plus or minus the square root of 0. Okay. So if we get this case, we already know that the square root of 4 is 2, right? So our answer would be 3 plus 2 and also 3 minus 2, right? So we see here that we get 2 solutions, right? 2 real solutions. It makes sense. Okay. And here, so what we're doing is we're comparing what kind of solutions and how many we get when we have a positive result in the square root, when we have a negative result in the square root, and when we have 0 as a result in the square root. Okay, so here we can see this square root of 4 is 2. So we have 3 plus 2 and 3 minus 2. So that gives us 2 real solutions. Over here, well, square root of negative 4 is 2i, right? 2i. So your answer would be 3 plus 2i and 3 minus 2i. So here, this would give us 2 complex solutions. And we covered complex numbers at the end of chapter 7. Okay, that's the imaginary stuff. Okay, so so far when you have a positive result in here, you get 2 real solutions. If you have a negative result in here, you get 2 complex solutions. Now, what about over here? What if we get 0? Well, then you get 3 plus 0 and 3 minus 0. But 3 plus 0 and 3 minus 0 are the same, right? So over here, you get 1 solution, and it's not imaginary, so it's 1 real solution. Okay, so these examples here are just sort of some concrete examples for the general rule about the discriminant. So remember, inside the radical, inside the square root, that's the discriminant. So we're going to go ahead and list the rules here about what happens when you have when your discriminant is positive, when your discriminant is negative, and when your discriminant is 0. And we can see this. So hopefully you'll have this visual here to help you think it through if you decide not to memorize the rules. Okay. Okay, so in general, all right, so if b squared minus 4ac, if the discriminant is positive, then you get 2 real solutions. Okay? If b squared minus 4ac is negative, okay? If it's negative, then you get 2 complex solutions. So that's when you have the imaginaries. Okay? And then if b squared minus 4ac equals 0, then you get only 1 real solution. Okay, so this is case 1, this is case 2, and this is your third case over here. Okay, and these rules match up with this up here. Okay, so let's take a look at some examples. Uh-oh. All right, I thought that was my screen recorder stopping. It is not, thank goodness. Okay. All right, let's take a look at this. Example 1, determine the number and type of solutions for each. Okay, so let's take a look here. X squared plus x plus 1 equals 0. All right, so A is 1, B is 1, C is 1. All right, so we want to know what sort of result do we get with this, okay? All right, B is 1, A is 1, C is 1, and we get 1 minus 4. And this is negative. We get negative under the square root, so that's going to give us imaginary. So this means we get 2 complex solutions. Okay? And let's try this one. Suppose we have this 3x squared plus 5x plus 2 equals 0. Okay, so A equals 3, B equals 5, C equals 2. So when we plug that into b squared minus 4ac, let's see what we get. So b is 5, a is 3, c is 2. So that's 25, and that's going to give me 24 minus 24, and that gives me 1. Okay, so 1, square root of 1. Okay, so that gives us 2 real solutions. Okay, so that's how it works. Pretty straightforward there. And it makes sense why we get 2 complex solutions, 2 real solutions, especially if you look at it here in terms of these examples here. Okay. All right, so let's talk about the second topic in this section, quadratic in form. So quadratic equations that are quadratic in its structure. Okay, so quadratic in form. So we already know what a quadratic is. It's a degree 2. So quadratic looks like this. Ax squared plus bx plus c equals 0, right? So quadratic in form would look very similar. Here, it looks like it's one word. Okay. Quadratic in form would have a very similar structure, except that this could be any exponent, so long as it's twice as much as this one here. Okay. Some examples. So something like this: x to the 4th plus 2x squared minus 3. Okay, that's not a quadratic, but it is, this is twice as much as that one, so this is quadratic in form. This one, x to the 6th minus x cubed plus 2 equals 0. Not a quadratic, because remember, quadratics are degree 2. Okay, but it is quadratic in form because this is twice as much as that one. And another example, something that looks like this: x plus x to the 1/2 minus 1 equals 0. This is also quadratic in form because 1, right, this is an exponent of 1, and 1 is 2 times 1/2. Okay, so all 3 of these are examples of quadratic in form. Okay, so what we're going to do here is we're going to take a look at how to solve these using, we can use the substitution method. Okay. All right, so solving by substitution method. All right, so let's suppose that we are trying to solve this here. X to the 4th minus 3x squared minus 4 equals 0. Okay, we already looked at how to solve these by factoring. We looked at that in early chapters. Okay, so we're going to look at how to use a substitution instead. Okay, so clearly this is quadratic in form, right? And so what we normally do is we let u equal this this here, x squared, or whatever it is. Maybe it's an x cubed, or maybe it's an x to the 1/2, whatever it is, okay? So we're going to go ahead and we're going to let u equals x squared, okay? So then if I square both of these, right, then if I square that and I square this, I'll get this, right? Okay, so if I let u represent that, okay, then u squared would be equal to x to the 4th, right? And so what I can do here is I can substitute. So since x to the 4th is equal to u squared, I'm going to replace the x to the 4th with u squared. And since x squared equals u, I'll replace the x squared with u. And then I can use any of the methods that we learned about for how to solve a quadratic. So I'm going to go ahead and see if I can factor here. So u and u, positive and negative. It's either 1 and 4 or 2 and 2. Looks like it's going to be 4 here and 1 here. And I believe that gives me -3 for the middle. It does. Okay, so this is the correct factorization. And so then u plus 1 equals 0, u minus 4 equals 0. Subtract 1, so u equals -1. Add 4, so u equals to 4. Okay, but we don't, this is not our answer because our variable is not u, our variable is x, right? So then we're going to go ahead and back substitute. So u equals -1. So let's look in here. What is u? X squared. So then go ahead and now replace the u with x squared because we want to bring it here. So now back substitute. Let's bring our x's back. So use x squared. So I'll replace the u with x squared. X squared equals 4. And now I'll solve for x squared. Okay, so I have to take the square root of that, plus minus. So x equals plus minus I. And over here, take the square root, and x equals plus or minus 2. Okay, so we get these 4 answers. Okay, so again, you start by letting u represent this middle one over here, just the variable part, not the coefficient. And then when you square both sides, square this, and you get this. And then you can substitute. Since x to the 4th equals u squared, replace x to the 4th with u squared. And since x squared equals u, then replace x squared with u. And then solve it like it's a quadratic. And then once you solve for the u, now go back and substitute and solve for x, because our variable is x, not u. Okay? Yeah, so when you do this back substitution, remember, u equals x. So replace this u with x. Okay? Oops, it's x squared. Okay? So it's x squared equals -1. X squared equals 4. And then solve. Okay? Let's take a look at another example. Let's go ahead and solve x minus 7 times the square root of x. plus 12 equals 0. Okay, and we already know that another way to look at square roots is by using fraction exponents. So let's go ahead and do that. And is this quadratic in form? Yes, because 2 times 1/2 is 1, and that's what we have here. Okay? All right, so I'm going to go ahead and I'm going to let u equal x to the 1/2. And then if I square both of these, if I square this, I get u squared. And then if I square this, I get x. I get x. Okay, so x equals u squared. So I'm going to replace this x with u squared. And then x to the 1/2 equals u. So I'll replace this x to the 1/2 with u. So what we're doing here is we know it's quadratic in form, and so we do this substitution thing here so that we rewrite it as a quadratic that is more familiar to us. Okay? And then here, I'm going to go ahead and see if this factors. U times u, negative and negative, 3 and 4, and that gives us -7 for the middle. So u minus 3 equals 0. Add 3. So u equals 3. U minus 4 equals 0. So add 4. So u equals 4. But again, u is not our variable. U is equal to x to the 1/2, which is square root x, right? Okay, so I'm going to back substitute. Okay, so u is square root x. So I'm going to say square root x equals 3 and square root x equals 4. Okay, and now I'm going to solve this. So remember, square and square root cancel. So I'm going to go ahead and square both sides. Oops. So I'm going to go ahead and square that. And so we get x equals 9. Okay, and then here I'm going to square both sides. Okay, and I get x equals 16. Okay, now when you're dealing with solving for x under a square root, when you're dealing with that, remember when we were solving radical equations, here I'll put a note here, solving radical equations, need to check solutions. Okay, because maybe the ones that you got don't work out. Okay. All right, so here it actually turns out that they both work out, but you can check on your own. Okay, let's take a look. Let's do another one. And you know you have radicals if you're dealing with fraction exponents, okay? So let's take a look at this one. Solve 2m to the 2/3 minus 2 equals 3m to the 1/3. Okay, so first of all, let's get them all on the same side. So let's subtract 3. Let's subtract this one, 3m to the 1/3. Okay, so this one is twice as much as that one. So this will be my leading term, and then this will go next, and then minus 2. Okay, so 2m to the 2/3, and then minus 3m to the 1/3, and then minus 2 equals 0. Okay, set it equal to 0. All right, so this is quadratic in form because this is twice as much as 1/3. Okay. All right, so I'm going to let u equal m to the 1/3. And if I square u, I get u squared. And if I square this side, I get m to the 2/3. Okay. Okay, so we have fraction exponents, so we know we have to, we're dealing with radicals, so we know we need to check our solutions at the end. Okay. All right, so let's go ahead and substitute. So this is going to be 2u squared minus 3u minus 2 equals 0. Okay. And I'm going to go ahead and factor this out. So it's 2u times 1u. And it's going to be plus minus. Maybe they have to be switched. Maybe the first one's minus, the other one's plus. But that's an easy fix if that's the case. All right, 1 here, 2 here, and let's check. Outside gives me -4, plus 1 is -3. Okay, so this is done correctly. So 2u plus 1 equals 0. Subtract 1 on both sides. I get 2u equals -1. Divide both sides by 2. And u equals -1/2. The other factor, u minus 2 equals 0. Add 2 to both sides. So u equals to 2. Okay, so now we're going to go ahead and back substitute. And let's see, what is u? U is m to the 1/3. M to the 1/3 is the same as cube root. Okay, so cube root m equals -1/2. Cube root m equals, what is this one? 2. Okay. All right, so we're going to go ahead and get rid of that cube root by cubing both sides. Okay. So we're going to do this to cancel that. We'll do that. We're going to do that here too. We're going to cube both sides to cancel that. All right, so I get m equals, and that's going to give me -1/8. And we'll need to check this again because we have radicals. And then over here, this is going to give me m equals +8. Okay. We have radicals, so check answers. Okay. All right, and let's take a look at this next one. Let's go ahead and solve 4t plus 2 squared minus 30 times 4t plus 2 plus 224 equals 0. Okay, so this here is quadratic in form because both of these are 4t plus 2. This one's to the first, and this is twice as much. Okay, so I'm going to let u equal 4t plus 2. Okay, then when I square this side, I get u squared. And when I square this side, I get this thing squared. Okay, so I'm going to replace the 4t2 squared with u squared. Minus 30 times u plus 224 equals 0. Okay, let's see. Okay, so we've got some pretty big numbers here. If this takes you too long to try to figure out how to factor this, then you can always use a quadratic formula. Okay, so just keep that in mind. Okay, so this here, I believe, is u times u. Signs have to be the same, both of them negative. And I believe it is going to be 16 times 14. Again, if you're like, I don't think that would take me forever to try to factor that, again, just use the quadratic formula. Okay, so it is. So it's 16 times 14, and that gives me the 224, and it also gives me the negative 30. Okay. So u minus 16 equals 0. Add 16. Over here, u minus 14 equals 0. Add 14. Okay. And then we're going to go ahead and back substitute now. What is u? 4t plus 2. So 4t plus 2 equals 16, and 4t plus 2 equals 14. And let's solve each of these. Minus 2, minus 2. Divide by 4, divide by 4. So that's 7 over 2. And this one, subtract 2, subtract 2. 4t equals 12. Divide by 4, divide by 4. T equals 3. We don't have any radicals. Okay. So t equals 7/2 and t equals 3. Okay, one last example. All right. Let's have a look at this one. This one has negative exponents. But nonetheless, it is quadratic in form because this exponent here is twice as much as that one. All right, so I'm going to let u equal a to the negative 1. Then if I square this, I get u squared. If I square this, I get a negative 2. Okay, so now I can replace these. Replace this one with u squared, replace this one with u. So 15u squared minus 8u plus 1 equals 0. Okay, and then we can factor this out. Let's try 5u and 3u, minus and minus. One way to make 1. And that gives us negative 8u for the middle term. Okay, so 5u minus 1 equals 0. Add 1. 5u equals 1. Divide by 5. U equals to 1/5. Let's do the other factor. 3u minus 1 equals 0. Add 1. 3u equals 1. Divide both sides by 3. U equals to 1/3. Okay, so back substitute. Okay, so u is a negative 1. All right, so a to the negative 1 equals 1/5. A negative 1 equals 1/3. Okay, so this one's a little bit different. A to the negative 1 is actually 1 over a. Okay, so 1 over a. Okay, so different ways to solve something like this. I mean, it already makes sense, but in case it doesn't line up nicely like this, remember you could cross multiply. A times 1 equals 5 times 1. So that A equals 5. Same thing here. A times 1 equals 3 times 1. So A equals 3. Okay. Here, because these are rationals, A is in the denominator, you want to check these. These are rationals, not radicals, but rationals, fractions with the variable in the denominators. So check answers. Remember, we don't want to get 0 in the denominator and make it undefined. Okay, so that is it for 8.3. We only have 2 more sections left, and we're done with chapter 8. Okay, make sure you email me or text me if you have questions.